All right, engineers, I'm going to show you an example of how to start thinking about the logic behind code and then making that logic turn into code by using the example of playing cards and sorting them. So here's an example of 52 cards. There's 4 suits with 13 each. And our first challenge is going to be sorting these black cards from the red and then putting them on a pile on the left. So my suggestion is to start with a flow chart. So this is a good way to organize your thoughts and start kind of figuring out how that goes into code. So a flowchart always begins with our start oval, and the next thing is really just to ask a question and figure out, is the card black, right? There's only 2 possible answers to this, as there should always be in a flowchart. So if yes, then what we want to do is put that card in a pile on the left, and if no, then we're going to put that card in a pile on the right. Now at this point it might seem like that's it, we're done, except that if you think about it, we've actually only sorted 1 card. So we've just checked if it's black or not. So now we need to figure out, well, are there cards left? Because if we have a whole deck of cards, well, then obviously we have to go through this process a lot more. So we should check, are there cards left? And both of these options lead to that, because we need to see what do we do next. And if there are not, then we can just end. That's it. However, if there are, you could argue that we have to go back to, is the card black, and then putting it on the left or the right. So you could end up with this kind of chain reaction here, right? Asking a few more questions, and then on and on and on and on. You could end up with, 52 of these, really, right, to get through all the cards. However, as we know, there's a better, more efficient way to go about this. So instead of going on and on and on and on down here, if the answer is yes, we could just go back to the beginning where we said, is the card black? So that is what we call a loop. So we don't have to keep writing on and on 52 times. And computers are smart enough to count how many times you've done this. So we can do this 52 times if we need. We should also consider if there are no cards left, though, that still leads to the end of the program. So let's put this in code form. So I'm going to move this a little bit over to the side, and our start here is always going to translate into just that task main that we're used to seeing at the beginning of code. All right, keep in mind that you should always have these curly braces open and closed under task main, because that says everything inside these curly braces is part of your code. And really you should think about it as the open curly brace up here as your start, and then the end is the end curly brace, or the closed one. So let's go on to the next line. So this is a question. You're going to be branching into a yes or no. So that should be the first indication that we're not going to be dealing with just a straight few steps of code. We need to actually now use an if statement. So branching means if statement. So what I did here is I put the if. You should always kind of put the structure in there just so you don't forget any of these little syntax things, like the if, parentheses, parentheses. Make sure this is lowercase, and then open and curly brace. And that means if some condition inside these parentheses, then we're going to do only what's inside these curly braces. So to figure that out, the question is the card black? So really my condition is checking the color of the card. So now notice I've added some language here that I just made up. So this is not a real command that you can use in Robot C, but we need to keep in mind that talking about the card is not the same as talking about the color of the card. So I need to ask the computer to look for the color of the card and check if that is equal to black. Because the card itself could have lots of different characteristics, right? It could be black, it could be the number 3, it could be spade. So in our Robot C, we've seen that we need to have some sort of command here, like sensor value, if we want to read what the sensor is doing. So just for further clarification, the dark blue command is helping retrieve information about the card. All right, so then our next step is to figure out what to do. So that would be this rectangle right here. We're going to put the card in a pile on the left. So I just put that in pseudocode, or comments for right now, because I don't have commands for this. This is a purely theoretical example. So that would be where you put the command to put the card in the left pile. So then we need to consider, well, what is happening on the other side if we are saying no, if the card is not black. So then in that case, we need to have an else statement. So if the card is black, that's this branch right here. Else is going to be referring to this branch right up here. So then our action is to put that card in the right pile. So that looks like we've got most of it. If we continue though, we need to make sure we are looping. So both of these, the yes and the no, go to checking if there are cards left. So that means we're outside of the curly braces of both the if and the else. We're right down here after this else curly brace to figure out how do we check, are there cards left? And if you recall, we only know one kind of loop right now, so we are going to use a while loop. So I'm going to take all of this and I'm going to move it a little bit over because all of this will happen as long as there are cards left, if this is a yes. So basically, I put this command here, while, and I made up another thing. The number of cards is greater than or equal to 1. So meaning we don't have 0 cards left. Anything bigger than or equal to 1. Or you could even say greater than 0 here. There's 2 different ways you can get the same effect. So if that's true, because this is yes right here, if the number of cards is greater than or equal to 1, then we're going to do all of this stuff that we had just written. And I just indented it over, so it's very easy to read what's happening inside the curly braces under the while loop. So notice up till now, we've been using curly braces under task main, open and closed, as well as while, open and closed, if, open and closed, and else, open and closed. And notice all of these things also have something else in common that is different than all the commands we've used before now. And that's at the end of the line. So none of these, well, first task main, while, and if have these parentheses, but none of these have semicolons at the end of them. If you put a semicolon, that means that statement is done. The computer isn't going to look further. So you don't want a semicolon here, so the computer looks at, well, this is the actual action that follows this condition. So let's take a look and see what to do after that. If there are no cards left, so while the number of cards is greater than or equal to 1, we're going to stay over here. But once that becomes false, if there are 0 cards, then we're going to just end the program. And that should lead directly to that curly brace at the end of task main. So just to confirm that we've got all the curly braces that we need, I'm going to check here. And I should see all of my open and closed curly braces aligned. Now this doesn't affect the code if your curly braces are not aligned. The computer can read them without indentation, but this is purely for you and for me. When we're looking at the code, it should be very simple to see that we've matched all these, because if they are not matched, then you know your code will not compile. And then it's also just harder for me to understand what you're trying to do with your logic, because I should be able to see all of this happens while this condition is true, and so it's enveloped, it's inside those curly braces. And then meanwhile, all of these things are inside of task main, which has the curly braces all the way on the left. All right, so let's try a slightly harder example, and you can start the second video to watch that.